Hello, everybody, and welcome to this month's Newcastle Discover webinar, the latest in our Discover series. The Newcastle Discover series is brought to you by our Newcastle University alumni engagement team and aims to promote lifelong learning through thought-provoking and insightful events on the latest in university research and practical life skills. My name's Lily Moore, I'm the Alumni Engagement Manager here at Newcastle, and I'll be the host for today's event. As always, a massive thank you to everyone for joining us today. So, moving on to the content of today's event, Through Space and Time, Astronomy and Telescopes in North East England. Did you know that some of the earliest ideas around island universes, now known as galaxies, and the mysterious dark matter were developed in the northeast of England? This month's Newcastle Discover webinar is here to explore a project led by a team at Newcastle University on how the northeast of England has played a major role in the historical development of astronomy research, telescope design, and telescope manufacture. We are delighted to be joined here today by Dr. Chris Harrison, who holds a Future Leaders Fellowship, which he uses to lead a team of astrophysicists studying galaxies and supermassive black holes at Newcastle. Before arriving at Newcastle in 2020, he worked at the headquarters of the European Southern Observatory in Germany. In addition to his astronomy research, Chris works extensively on improving access to astronomy through developing public engagement and educational resources. He also leads the Audio Universe project, which is a multidisciplinary project to develop methods to represent astronomical data through sound. This aims to make astronomy more accessible to those who have low vision, as well as making more engaging and immersive experiences for all. We're also joined by Dr. Vicky Fawcett. Vicky is a research associate with the Astrophysics and Observational Cosmology Group at Newcastle University. She arrived in the group after completing her PhD in 2022 at Durham. Her research is about understanding the properties of and evolution of supermassive black holes and the role that they play in the evolution of galaxies. She uses telescopes from around the world to achieve this and is passionate about sharing astronomy research and discoveries as widely as possible. To finish off our speakers today, we have Dr. Holly Middleton-Spencer. Holly is a research associate in theoretical physics at Birmingham University, modelling vortices in extra-dimensional space, having recently finished her PhD at Newcastle University, where she modelled turbulence at ultra-cold temperatures. During her PhD, she discovered the proclivity for history of mathematics and physics, with a focus on mathematical and astronomical achievements in ancient Middle East. She's also won awards for her writing on disseminating research-level physics to a general audience on the history of science. So without further ado, I will hand over to our presenters for today.
Hi everyone, it's great to be here virtually today. So we're going to talk a bit about a project that we've been working on for the last year called Space Investigators Astronomy in the Northeast. Okay. So just kind of going over the basics of what this project is. So we developed a 5-month museum exhibition that is currently taking place at the Great North Museum, Hancock, here in Newcastle, that's focusing on the historical and current contributions of the Northeast of England to worldwide astronomy. So this museum exhibition, it opened on the 29th of March and it's running for 5 months until the 1st of September. So plenty of time for you all to go and have a look at it. So how did we kind of put this exhibition together? So it was primarily funded via a Science and Technology Facilities Council, or STFC, Spark Award, and then also contributions from Newcastle University and the Great North Museum, Hancock. But probably a more interesting question to ask is, why did we actually decide to do this? Why did we want to put on this exhibition? So this is kind of the top level aim that we wanted to get across with this museum exhibition, which is to increase the understanding and appreciation for astronomy in the northeast of England, with a particular focus on inspiring school pupils from areas of low socioeconomic background to consider pursuing STEM subjects or STEM careers. So just breaking this aim down a little bit more, I've kind of split it into 3 key points. First of all, we want to raise this awareness of the historical contributions that Holly's going to talk about in a little bit. And primarily, we want to inspire young people to engage with STEM. And why are we focusing on the Northeast to do this? So unfortunately, a couple of statistics, the northeast of England has the lowest percentage of young people in the UK who say a career in science would interest them. And it also has the equal highest child poverty in the country. And the two of these factors together just means that children from the northeast of England are just less likely to want to do science, either at university or in a career. And finally, we want to demonstrate that today astronomy is for everyone. And Chris will talk about this a little bit later. So I'm now going to hand over to Holly, who's going to talk a little bit about the historical contributions of the Northeast to astronomy that kind of was the backbone of this exhibition. So, Holly.
Hi. Hi, everyone. So today I'm going to talk about the more historical aspects of the exhibit. People have long been fascinated with astronomy and the sky since the dawn of time. Every single culture has its own creation myths, its own folk tales revolving the sky around us, and also the stars and other objects in the sky. Many of these cultures further went on to develop ways of measuring and observing the sky. General timekeeping, agriculture, navigation, celebrations, holidays, they're all essential to the human experience that we all experience, and thus are important things to not only document to keep an eye on what's happened in the past, also many different cultures need to predict what will occur at either during the year or in further years. So astronomy is essential. So we have three examples here of different cultures' historical perspectives on astronomy. So, for example, on the left here, we have a Mayan book from the 11th century. It's thought to originate from South Mexico, and it's one of the only Mayan texts we still have in existence. And it's actually a book of astronomical tables. So it keeps an eye. It's basically a calendar of what's going on in the sky and what corresponds to what's going on the Earth they saw around them. In the middle here, we have an Assyrian star planisphere from Nineveh, which is in modern-day Mosul, Iraq, and that dates back from 600 BCE. So you can see a sort of star map emanating from the center. And on the right here, we have a Chinese star chart from a court astronomer in the Chinese dynasty called Sun Song, and this is from around 1000 BCE. So, and the northeast of England has contributed to this global perspective on astronomy greatly. And if you go to the next slide, Vicky, sorry. And yes, so the Northeast has long been intricately involved in these astronomical endeavors. It has at least 1300 years of history that we know about. This slide is barely a small fraction of what is achieved from the early days of Bede on the left from 700s to the present day with the James Webb telescope, which currently sits above us somewhere in the sky. Next slide, please. So you might want to ask, why the Northeast? Scientific progress is not achieved in a vacuum. The golden ages and renaissances of scientific achievements, specifically in astronomy, are often linked to golden ages of art, of prosperity of areas, and it's also linked with money. So areas of large industry, which are generating a lot of wealth, often end up being very good places to be a scientist, because back in the olden days, you were paid by rich men to do science. So if you go to the next slide, Vicky. So in the early history, the Northeast, as most of us will know, is has a very strong ecclesiastical history. And in the Middle Ages, so we're talking from about 500 to about 1500, most education in what is now the United Kingdom and also other parts of Western Europe was conducted within monasteries and other Christian centers of learning. Monks typically would study the quadrivium, and this is a type of learning since the late classical Greek age, where you would study arithmetic, you would study geometry, you'd study music, and finally you'd also study astronomy. And so most monks, the vast majority of monks, would have had to take this course when they were training and continue it throughout their lives. This was regarded as a central part of monkhood. And the Northeast, as I said, has a very strong monasteric tradition. Early examples include Lindisfarne, Monk Wearmouth Jarrow Abbey, which is in the centre here, and slightly later with Durham Priory. And education was often done in-house. Older monks would teach younger monks. How from texts they would themselves make and copy and write on, so these texts would grow. However, monks in Durham were also sent away to Oxford. So on the right here we have what was then Durham College, one of the first colleges of Durham, which is now a part of Trinity College. And again, these monks would often copy and add upon these textbooks and documents. They would often unnamed, but sometimes they would write their names. And one person was, for example, is Bede, this is a later edition of his text on the left. And he was one of the most famous monks in medieval time. He wrote he's most famous for his writing of the history of the English people, but he also completed many other important astronomical works, such as De Rerum Rationale, The Reckoning of Time, where he made a way of the computus, which is using the sky to calculate when Easter would be, etc. And also we have another great example, a man called John of Westwick, who was in Tynemouth Priory in the late 1300s. He was originally in St. Albans, but he was sent to Tynemouth Priory because he had been a bad monk and therefore he needed to be punished. So he was sent to the north. And he wrote the Equatory of Planets, which is a very famous textbook written in Middle English and not Latin. So it was for ordinary people, so they could also understand what was happening in astronomy and use that for their farming. Next slide, please. And another example, as I said earlier, the Northeast, Newcastle, etc., has been a massive place of industry, and that's often associated with big scientific breakthroughs. And a very good example of this is Robert Stirling Newall, who lived in the 1800s. He was a Scottish engineer who ended up settling in Gateshead. He owned a company which designed and created new ways of transmitting data through undersea cables. We see this cable in the middle here. And it was wrapped in such a way that it was protected and it was also very sturdy. He would join his company out on the boats to lay cables between statistic locations. And he is often said that he is the man who quickened the ending of the Crimean War due to these cables and the intelligence that the British could receive. And thus he is credited with saving thousands of lives of soldiers who would have otherwise died. He became very wealthy from his patents and his companies, including the wire company, and his main love in life was astronomy. He thus decided to build the largest telescope in the world at that time, and it took many, many, many years. And unfortunately, Gateshead being Gateshead, there were too many clouds, and he is famously quoted as saying he is the only one good night of sighting after it was built. And you can actually see him on the left with his telescope in the observatory. His son also became a well-known professional astronomer in Cambridge and took the telescope down with him. And today it sits in Athens, and it's where it's being used to this day as a way of teaching astronomy to children and adults. And there is a replica of this telescope, a life-size replica of this telescope in the exhibit you can see alongside another Thomas Cook telescope, which is a very similar design and shape to this one, but much smaller. I must state that the smattering of history I've discussed here are only a small part of the total history of the region. If you want more information about, for example, Robert Newall and other people, or any others that we didn't have time to feature today, then you'll simply have to go to the exhibit. That's me.
Great, thanks, Holly. So yeah, all of this history, I'm not going to kind of cover any more of it, but in the exhibition we have lots of original artifacts and more information about kind of historical astronomers from the Northeast. So what I'm just going to talk about now is actually kind of revealing what does the exhibition look like, but only a snippet, so you still have to go and see it yourself. So on the 28th of March, we had an opening night at the exhibition at the Great North Museum, and here you can see a little photo of everyone having fun in the Great North Museum. So this was people that had helped build the exhibition, people from the museum and family and friends. And here's myself and Chris giving a little speech at the launch event. And we were really, I was very honoured that the MP for Newcastle Central, Chi Onwurah, actually came along to the launch event, and we had a chat, and she was very, very impressed and learned a lot about the Northeast and the link to astronomy, which she hadn't known before. So I'm going to just kind of dive straight in. Okay, there was a video just going around the exhibition, but it doesn't really matter. So here are two photos of the exhibition. So a couple of things just to note, and it was really hard to capture the entire thing with just a couple of photos, is on one of the walls we have a life-size replica of the James Webb Space Telescope mirror. So you can see all these gold hexagons. It's actually so big that we had to chop kind of the top off to actually fit it into the room. We also have this central area where kind of especially younger kids can kind of just chill. And there's this rolling projection that shows lots of different cool things from astronomy. And around this central plinth, we have interactive stations, which I'll talk about a little bit in a little bit. And then around the edge of the room, we kind of have more of our historical artifacts and different areas that focus on different times in the past, looking at Northeast kind of manufacturers and astronomers that Holly's mentioned just now. So here's a few more photos if the slide changes. Okay, anyway, so something that Holly's already mentioned, the Newcastle telescope, which was the largest telescope in the world at the time in Gateshead. We actually have a life-size model of the Newcastle telescope that was built by Chris and his dad. I've put a couple of artifacts here where we have a book by Copernicus, which was one of kind of the first times that they showed that actually the sun was in the center of the solar system and not the Earth. We have some sketches from Thomas Wright of Durham, who was one of the first people to think about some of the bright points in the sky and speculate that they're not all stars, that some of these points were in fact distant galaxies, which he called island universes. And we have some of his original sketches of what he thought these galaxies looked like. Something that gets kids very excited in this middle photo is a Lego model of the extremely large telescope. And this took kind of 5,000 Lego bricks and a lot of enthusiastic PhD students at Newcastle to build this over the last few months. The top right is one of the mirrors that was made by Grubb Parsons of Newcastle, who were a major manufacturing company in the 1900s. And they manufactured telescopes and telescope mirrors for telescopes all over the world, and some of which we still use today as astronomers. And the bottom right is the night telescope used by Lord Admiral Collingwood in the Battle of Trafalgar. So this is kind of just showing the kind of variety of things that we have in the exhibition. But what we really wanted to focus on in this exhibition is the hands-on interactives, because as much as we can make some text about how amazing the Northeast is in terms of astronomy, not all children are going to read the text. Not all children are going to look in the cabinets. So we really kind of a big push was to make this exhibition very hands-on and interactive. So I'll just run through a couple of the interactives that we have. We have this green screen that was coded by a Durham University PhD student. And I've just shown one of the images here, but it actually scales your height on the TV to whatever's being shown. So this is an example of the Angel of the North, and it will actually put you in scale next to the Angel of the North. And we also have some telescopes, such as the Newcastle telescope, the extremely large telescope, and the James Webb Space Telescope. And the idea is to give kids a sense of the kind of immense scale of some of these telescopes and comparing them to kind of famous landmarks in the northeast of England. And just to know, these are a couple of our summer students from last year that helped us put together this exhibition. So next up, we have an interactive that was created by Northumbria University, because a big push, we wanted to get Northumbria, Durham and Newcastle universities all collaborating on this project. And this is probably one of the most popular interactives, the exhibition, where you have this torch, you point it at a satellite, and the idea is to demonstrate optical communication between satellites. And when you make contact with the satellite, the song that you've chosen on the iPad plays from a speaker. So you can imagine kids like this are quite enthusiastic about this one. This one is a multi-wavelength interactive, which we outsourced. And Chris is going to talk about this in a bit more detail, but just kind of an overview is that you can select different wavelengths, so visible light or infrared light, and it's to show children that there is light beyond what we can see in the the electromagnetic spectrum. So here's just a couple of examples of kids mainly using the infrared camera because people love looking at themselves in infrared. And then finally, a couple more that Chris is going to cover in more detail. One demonstrating how telescopes work with lasers and lenses. And on the right, a kind of a jigsaw that demonstrates a size comparison of telescope mirrors. And these two were developed by Newcastle University. So the one on the left by our lab technicians and the one on the right by Chris. So just kind of finishing some of the highlights of the exhibition, what we have in our kind of now future zone, we wanted to demonstrate that today astronomy is for everyone, because obviously doing a project on the history of astronomy, we look at a lot of rich old white men because that's what astronomy was back in the day. But we really wanted to show that these days anyone can do astronomy, and to do this, we took a series of interviews of astronomers at Durham, Newcastle, and Northumbria universities, and just to showcase how diverse astronomy is today, but also to demonstrate how diverse what you study is. So you can see some snapshots here of the different interviews where we have people talking about satellites, the aurora, planets, galaxies, telescopes, cosmology, simulations, to kind of really demonstrate to children that astronomy, there's so many aspects to astronomy. Because whenever I talk to children, their first question is, have you been to space? And that's what children often think when they think of astronomy. They just assume you're an astronaut. So we want to kind of showcase that kind of how amazing astronomy is and all the different areas, well, just some of the areas that you can study. So I will now hand over to Chris, who will be talking about accessibility.
Thanks, Vicky. So yeah, I'm going to talk about how accessibility was a theme that we were running through with the design of the exhibition. And Vicky already mentioned that one of our goals is to show that accessibility is for everybody. And so as well as talking about the diversity in terms of not just being white men, we were thinking about people with disabilities, and that was a big theme that we're doing there. So Vicky, if you just bring up the whole slide, it'll be easier. So the goals here was to make the content of the exhibition as accessible as possible for everyone, including people with a vision impairment, hearing impairment, some neurodiversity. And we're working with focus groups to try and achieve that. And at the end of the exhibition, we're hopefully going to do an evaluation study, and we'll see what we achieved and what worked well and what didn't work so well. So next slide, please. And we'll take the lessons learned from that and pass it on to the Great North Museum Hancock to help them with their future exhibition design, and then also more widely to other museums. And we can think about what we learned and how we can make museum exhibitions in general more accessible. This picks up on a theme that we've been working on recently from Newcastle University in a project called Audio Universe, where we've designed, for example, a planetarium show that's fully accessible to people with a sight impairment that represents everything through sound. We've been going into schools which have special units for sight impaired and hearing impaired pupils, doing multisensory workshops. You can see some photographs here of the tactile activities that we've been doing, for example. And we're now working on developing toolkits for science centres and teachers to take these activities and develop new ones themselves. So it's all part of this accessibility theme we've been working with. Next slide, please. So to help us achieve that, you can just bring up the whole slide each time, Vicky. I didn't think about me not controlling the slides. We've been working with focus groups, so we design it for the audience that it's intended. So for example, there's a group called the Views Group in Newcastle, which is a community group of adults with sight loss or who are blind. We've been working with some individuals who self-declare as having a neurodivergence of some description. And we've been working with school pupils and teachers, particularly from Newcastle Children's Visions team, which is a special group of teachers who support children across Newcastle with a vision impairment. So we've been talking to them, asking what their needs are, what they want to experience in an exhibition. And we presented some of our early ideas to these groups to say, what do you think is good? What do you think is bad? And what should we do to improve? Next slide, please. So I think, is this the video that may or may not play? So one of the people that we've been speaking to was an A-level student who's got a severe sight impairment and a teacher.
Hopefully this project has proven that there are no limitations on what you can achieve, regardless of need or disability.
I can definitely imagine using sound to develop my interest in science in the future. I was amazed at how much of it I felt like I could access.
So you heard from two of the people we're working from, and hopefully we're making a bit of a difference from them, and it's really been rewarding for us to learn from them as well as provide something that's more accessible for them. So what are the kind of features that we put in the exhibition with this accessibility idea in mind? So one thing was about simplicity of navigation. That was a theme that kept coming up. You don't want to be disorientated and have a complex space to navigate. So even the layout of how we laid out the exhibition was carefully considered, and it has a very simple design that you basically walk in a circle around the exhibition. Things on your right are the historical storyline and artifacts, and things in the middle are the interactive stations. On the whole, some little divergence from that, but you've got this very simple path to follow, and everything's neatly ordered, so it's very clear where you should go and where you should go next. And to help with understanding what to expect when you enter the exhibition, we did two things. One was we put some information online, so we have accessibility information on our website, so you can learn about how the exhibition works, how you can access it, the accessibility features, etc., which is also very important for people with neurodivergence who like to have very clear expectations of what they can expect in the space. And there's also a welcome station as you walk in. So when you walk into the space, the first thing that you experience is you'll hear the voice of our character Lyra. You'll have seen Lyra on the front slides. She's the guide through the exhibition, and she'll explain to you some of the accessibility features and welcome you. So if we can try and play that, Vicky, we'll give that a go. No, it doesn't want to load the audio. That's fine. So Lyra explains to you how each station is laid out, and I'll talk you through that in a minute, and sort of give you that introductory guide to access the content. Next slide, please. All right, that's just a visual representation of it. So one thing we did is each information station has a consistent layout. You can bring up all of that, Vicky. So here's just one example. So every station has a tactile mat in front of it, so you know that's somewhere you should stand, and that's the central point for standing. You'll see on the ground there's a tactile mat. The information, although with hindsight, I wish it was all a bit bigger, but that's fine, is laid out in a consistent way. So the layers of information is all very consistent. And then on the right here, you'll notice there's a QR code, and that's also tactile, so you can feel where that QR code is. And if you'd listened to Lyra at the beginning, you'll know that the QR code is always on the bottom right of the plinth. And if you scan that with your phone, it'll take you to the relevant page of the website, which is screen reader friendly. So you can have the information that's on the display read out to you via your phone using your standard screen readers. And the focus group information that we got was that's the best way. People like to use their own devices because they have their own favorite screen readers, etc. So we've gone with that approach, that people use their own device to access the information. And then to the right of that, there's also some large print panels of all of the information as well. So those who have some sight, but low vision and like to read the information, they can pick up those panels and bring them closer to themselves and to have a read. The other thing that's online, if you go to the QR code, is photographs of all of the content. And we've applied alt text to those images. So if you want a audio description of the artifacts in the cabinet, that's also available through the QR code. Okay, next slide, please. And then when it came to the interactive stations that Vicky already briefly introduced, we also wanted these to be as accessible as possible. Now, this is extremely challenging, and I look forward to the evaluation to see how well we've achieved this, but I'll explain some of the things we've attempted to do, and we'll see whether we were successful or not. So this interactive that Vicky introduced demonstrates that when you look at objects in space with different types of light, like there's a visible light we see with our eyes, there's X-rays and infrared light, all these different light, you learn different things and you can see different things. So on the table, there's a model of a patch of sky, which is on the right of the table. And you see lots of stars around the outside, but in the center, there's this black patch. So if you look at it with visible light, it looks completely black. But if you look at it with infrared light, light beyond red, which is shown in the screen in the picture in the top right, you actually see there are stars inside that black patch. You just can't see them with your eyes. So you need a special camera and those stars pop out. Now on the model, we've made the stars tactile. So if you run your hand over the model, you can feel where those stars are, even if you can't see them. And I think there's another photo, Vicky. And if you look at this in even longer wavelengths of light, so you're pushing even further into the red beyond what we can see, this patch of light glows. It's because it's actually warm dust that's there. And this glows in these long wavelengths. And that is the dust that's blocking our ability to see the stars with visible light. And you can see that glowing on the screen and that new picture. And on the model, it's actually warm. You can actually feel that temperature there. So that patch of the model actually feels warm. So it creates this sort of sensory way of accessing the information as well. Next slide, please. This is our sort of the most young kid-friendly interactive that we have, but it's also designed to be an accessible way to understand the different sizes of telescope mirrors, because a long time ago, telescope mirrors were relatively small, and nowadays we have giant mirrors all the way to the extremely large telescope, which is 40 meters across. And normally this is represented visually. So we wanted to come up with a way of measuring, representing this in a more tactile way. So the idea is that everything is to the scale of a football pitch. So everything is matched to this scale. So you can feel the size of this rectangle on the jigsaw. And then each piece of the jigsaw represents a different telescope mirror. So there's a zoom in here of Amrit Singh, who's one of our best focus group members. He's always giving us great feedback. He's completely blind, also has a physical disability. And he's currently picking up the piece that has the James Webb Space Telescope on it, which is tactile. Now, you might notice there are these different shapes. So on top of each shape is the mirror, but the shape itself is a tactile key or legend. So if you're accessing this on your own through our website, you can listen and say, oh, if you pick up the trapezium shaped piece, that's the James Webb Space Telescope. If you pick up the triangular piece, that's the Isaac Newton Telescope. So it gives you a way of interacting and understanding what you're picking up without having to be able to read the information. Next slide, please. So yeah, this is just, I put these slides backwards. This is just what normally you would sort of do to represent this. This is a visual representation of all of these different mirrors. And again, there's a couple of pictures of like basketball courts on the bottom. So we basically made a tactile version of that. Thank you, Vicky. Next one. This interactive is about how telescopes work. So the way it works, if visually, is you can see the laser beams move through the optical setup. So what we have on the screen here is a telescope designed with two lenses, which is like a traditional refracting telescope would say. And those two lenses converge the light and focus it to a point before then sending it to the eyepiece. And the way we've set this up is you can use that red block that's on the screen and see, depending on how you move these lenses around, you can see how the light's focused. What we did to make that more accessible is we printed on what we call swell form printer, a tactile version of how the light rays pass through the optical design. So on the bottom right of this slide shows you a picture of how the lasers move. And we use this special printer called a swell form printer, which makes the black lines risen. And so there's sort of an example there. It's maybe hard to see, but if you move your hand across that piece of paper, you can feel where the lines are. So you can get a tactile feeling of how those laser beams are moving through the telescope design. Thank you, Vicky. Okay, so what's next? We know that there were some limitations in what we've already done. So for example, we wanted the exhibition space to be very quiet because we know from neurodivergence perspective, having lots of background noise can be intimidating and confusing and distracting. Now, unfortunately, we couldn't buy all of the equipment we needed to make sure all of the background sounds were not going around the room. And the acoustics of the room are also quite poor, that it's very echoey. So that wasn't ideal. But one way we can overcome that is we can organize some quiet visits. So where we turn all the sounds off and make sure it's a quiet and a calm experience for people who prefer that. We didn't manage to get any Braille into the exhibition. It's sort of a cost and manufacturing challenge, limitation there. And we already had some feedback on that tactile scale model of the mirrors. Braille would have been helpful. And we already know that it's maybe not the easiest to find the QR codes if you don't know they're there. So we could think about ways of making it more obvious. But as I said, we're going to now perform an evaluation study over the summer. We'll invite some of our focus groups back and we'll get them to go around, see how they interact with it, get some written up information about what worked, what didn't work, and then hopefully pass on those lessons learned to the Great North Museum Hancock to use in the future and also other museums around the country. I think that's me. Pass back to Vicky.
Great, thanks, Chris. So just in the last 5 minutes, I'm just going to summarize kind of the exhibition and what we've learned so far. So bear in mind the exhibition's been open for 3 weeks now. So one of the biggest lessons, which was a bit hard to take, is if it can be broken, children will break it. So even if you have do not touch signs, even if things are bolted to the table, children will still find a way to break things. So that was kind of a learning curve for us, because it's the first time that we've built interactives that are unmanned. So we're kind of now developing new ways to have things that are more robust and looking into ways to kind of rebuild some of the interactives that are already there, but to make sure that they will last for maybe 5 months, maybe a few years. So just to quickly do a little bit of evaluation, but this is only from about 40 people that filled out our evaluation cards. Out of these 40 people, 75% said they were either more or similarly interested in science, which is great. That's kind of what we wanted. And then something that interested me is that 63% of mainly children answered that somebody in their family either uses science in their job or as a hobby. And this is interesting because we asked the exact same question to 3 of our focus group schools last year when we were developing the exhibition. So a school in County Durham and 2 schools in Newcastle. We asked them the exact same question. And what we got was about 34% of students at these schools said answered yes to the same question. So something that we've learned, which maybe is a fairly obvious statement, is parents who like science will bring their children to science exhibitions. This is quite a sweeping statement, and obviously there's exceptions, but this is something that we have to think about and we have to tackle, is how do we kind of tap into the population of people that do not have family members that want to take them to museums on the weekend. So that's something that we're thinking about now. We also got them to draw or write something that they learned today. And as you can see, with children, rockets and the moon are still probably the most popular topics in astronomy. And something else we learned is how we worded this question. We said, draw something you learned today. Children take this very literally and just were writing anything that they learned throughout the entire day. So you can see dinosaurs came up quite a few times, which is still great. It's still nice that they're engaged with dinosaurs and that they enjoyed the rest of the museum. And then just finally, I'm just going to kind of outline the next steps. So the exhibition's up and running now. We're still kind of keeping an eye on things and, like I said, improving some of the interactives. But what we really want to do is undertake a full evaluation of the exhibition, like Chris mentioned, and we actually have an undergraduate this summer that's going to do this in a lot of detail. I'm going to publish some articles on the exhibition and also the historical write-up that Holly's been working on. And then something that I'm very keen to do to kind of tackle this issue of who actually turns up to museums is to develop school workshops that are kind of centered around the same theme as the exhibition, that will be delivered by the museum's educational team. And Kilda Observatory have also agreed to incorporate any astronomy workshops into their educational program, and then also by volunteers at the university. And then kind of the longer term goal would be then to turn these workshops into a kit. So essentially a little box that contains all the materials and the instructions that a teacher would need to deliver this workshop themselves. And we'll also attend teacher training events to demonstrate the workshop and then disseminate these kits in schools around the northeast of England. And because the best way to reach kind of an unbiased population of children is to basically go to schools, because they have to turn up to school. So that's kind of how we're tackling the other side of things, of how to bring astronomy to kind of the wider population. And that's all from us. Thank you very much. And we're happy to take any questions that you have.
Amazing. Thank you all so much. And just for such an insightful talk, not just about the exhibition, but about, I mean, I'm born and bred in the Northeast, and I had no idea that we had such a rich history of astronomy here in our region. So a massive thank you for the presentation, guys. So we are now moving into kind of 15-ish minutes of questions and answers with our presenters today. So anyone who is still with us, please submit any questions that you have about the exhibition, about the history of astronomy in the Northeast via the Q&A function, and I will pick those up and ask those on your behalf. We have had some pre-submitted questions today, and some of these are, I guess, more broad astronomy questions. So I hope that's okay with our presenters today. But I'm going to go back for the first one, thinking about the history in our region. And someone's asked a question around the history of dark skies in the Northeast. And I think, Chris, were you going to take this one?
Yes. Yeah, thanks, Lee. So I wasn't entirely sure what was being asked here, but there was sort of, is there a connection between dark skies and the history of astronomy in the Northeast? Now, we were discussing this, so I don't believe that the Northeast historically has sort of more dark skies than anywhere else in terms of development. Now, I think some of the connections to the Northeast Holly touched upon. There's the history with the monasteries, there's the history with the mining, and that has driven a lot of the innovation that we've seen here. In terms of dark sky specifically, though, we have, and we still have, one of the darkest skies in the world, in Northumberland Forest, Kielder Forest, which has a protected dark sky status. It has done since 2013. I think it's maybe even the largest one in Europe. So if you are interested in amateur astronomy and you want to enjoy the night sky, it's one of the best places you could ever go in terms of, at least in the Northern Hemisphere, to enjoy the night sky. And my parents actually live there, and I can attest it's beautiful. The problem is the weather, and that is a big driving factor to why professional astronomy, in terms of observational work, building the telescopes, just doesn't happen in the Northeast. The New World Telescope was quickly moved. It's now in Athens, and a lot of that driving factor is the weather and suitable sites that are like high up.
Well, thank you. We've just had one question from Trevor, that's coming from, which is quite an important one, actually, I guess, to recap. He apologises he'd missed the first 20 minutes, but is really interested. Just a quick reminder of where the exhibition is and how long the exhibition is up for, please.
Yep, so the exhibition's at the Great North Museum Hancock in Newcastle, so kind of right by Newcastle University. And the exhibition's open now, and it's open until the 1st of September, so for 5 months.
Amazing, thank you. I'm going to go back to our pre-submitted question now, and I'm just going to, someone has asked, does Newcastle University play a part in designing any satellite payload components or aim to play a bigger role in future scientific payload instruments?
Yes, I was going to take that one as well. So Newcastle University doesn't have a huge role in that at the moment. Maybe it's something for the future. The region as a whole, though, does, northeast of England. So Northumbria University has a role in a new observatory, Solar Dynamics Observatory. It's developing new technology for laser communication between satellites, as mentioned by Vicky. That's part of the exhibition. And they're just investing in a massive new space science centre. That's in collaboration with the UK Space Agency and Lockheed Martin. So that's really great for the region. Durham University have also designed specific components for multiple observatories, including the James Webb Space Telescope. There's the Lunar Thermal, the mapper that's doing something with the moon. So the region as a whole has done a lot of that. Newcastle University is not one of the major players in terms of the region, but we may be in the future.
Amazing, thank you. I'm going to hopefully maybe merge these two last pre-submitted questions together. And I guess we could have never had an event around sort of astronomy and all those sorts of things and physics without asking a question around parallel universes and the Big Bang theory. So first question is, do parallel universes, or do you believe parallel universes really exist?
I guess this is quite an easy one to answer because we don't know. It's I'd like to think that parallel universes and what we call the multiverse, so more than one universe, is out there. I think it's a nice idea, but it's an extremely difficult theory to test. I think there's only been one prediction of, because in science you come up with a theory and you have a set of predictions that you can test, and if you test them, then that can tell you whether your theory is right or wrong. The multiverse theory is just very difficult to test, and I believe there's only been one prediction that there might be some background radiation that's been left over from two universes that have like interacted, like touched, but then they kind of concluded this radiation would be so low it would be pretty much not undetectable. So I guess the short answer is we don't know. It's just a theory, but it's very difficult to test, at least today. Maybe in the future we'll come up with more ideas. In terms of the Big Bang Theory, this is the widely accepted origin of the universe, is that we started at a kind of a point, and there was this Big Bang, and we've had this expanding universe. And in terms of theories of how the universe began that have testable predictions and have a wealth of evidence, the Big Bang Theory is pretty much the only one. There's some kind of adaptations to it. So there's something called the oscillating universe, and that's this idea that as our universe expands, maybe it gets to a point and it then crunches back down, and when it hits a point, it will then kind of explode again, and it's a big bang, and then you just have this forever. That's why it's called oscillating. But again, this is quite difficult to test. So yeah, the Big Bang Theory is the kind of accepted theory.
Brilliant, thank you. We've had a few questions coming through the Q&A, so I'll just work through as many as I can in the time we've got left. One of the questions we've had is, what is the title, origin / history of the old book within the exhibition, the heliocentric diagram? Does anyone know what to...
Do you know what the title of the Copernicus book is?
Yes, that's it.
Yeah, no, I'm sorry, I can't remember. Sorry, I can't remember off the top of my head.
That's fine, don't worry.
It's also in Latin, I think, so it's a bit difficult, but
Yeah.
Yeah, I might be able to look that up whilst we answer other questions.
No, that's absolutely fine. I'll leave that one pending for now. Trevor's come back with just a second follow-up question just about sort of engagement with young people. So Trevor is actually a member of 2 astronomy clubs and is asking, would you do presentations to the clubs and their children?
So I can partly answer this. I know that astronomers like myself regularly go to astronomical societies, so kind of amateur astronomical societies, and give talks. In terms of kind of younger clubs, I'm not sure, but we're always happy for people to reach out, and I regularly have teachers that reach out and ask if I can give a virtual or in-person talk about like black holes, and I'm always happy to give talks. So yeah, I'd say just if you want talks at whatever clubs you're involved in, just send an email to kind of us or Newcastle University, and I'm sure somebody will be happy to give a talk. I don't know if Chris wants to add to this, but
I agree. Yeah, that's true.
And I think message for everyone today is, if you're in the Northeast and able to get to the exhibition, for sure. I feel bad that I've not been. I can literally see the museum from where I'm delivering this talk from today. So we'll be over in very, very due course. So just going back to the questions, we've got probably time for another 1 or 2. So I'll just, sorry to anyone who I can't get to your question. So we've had a question just saying, thank you for a really inspiring early history of Northeast astronomical research. I did not know the early Northeast inventor of the cable, which is applied to the astronomical equipment. What type of cable was invented? Electrical and communication use, or an optical cable?
Electrical and communication.
Well, thank you. So Ian has asked, there are many different types of telescopes. They receive data in visible light, but also in X-rays, infrared, and radio waves. What is the process whereby this data is converted into something we can see?
Should I take that? Yeah, so that's a really great question, because this it resonates with me because I'm always thinking about how can we represent the data in different ways and not just with sight. So the light, all of the light exists in sort of waves or particles. You can think of different ways, and there are detectors, and it detects, you know, when some light reaches that detector. So that is sort of digital information, and that digital information you can then convert into an image. You can just say, oh, if I detect lots of light at that position in the image, I can make that brighter. And then somebody needs to make choices about what color that is, exactly what it looks like. So there is a little bit of choice in taking the information that the telescope picks up and then turning it into an image. For radio, particularly, it's quite complicated and it's not even direct. The way that the information you have is really a table of data, and then somebody has to reconstruct an image from that. So there's a lot of processing from the digital data at the telescope to making choices about what it looks like. Is, you know, why are X-rays blue in pictures? Well, somebody just made that choice. And so what I'm interested in is saying, oh, well, maybe we don't just use visual representations. We can make tactile representations or even use sound to represent it.
Amazing. Thank you, Chris. I've got a really nice question here from Hannah, who has asked, and this is one for everybody, what are your personal favourite parts of the exhibition?
I still probably the James Webb Space Telescope kind of mirror representation that we have on the wall, partly because it took us a long time to, it was more involved than I thought to put those kind of hexagons together. And I think it just gives a really nice kind of sense of scale. Like even myself, I'm not very good at imagining scales, so standing in the room and looking at it, I think it's very impressive, and it just highlights how amazing this kind of telescope that's actually we've sent into space is.
Holly, Chris, whoever wants to go next.
Do you want to go?
All right, I'll go first. So I really like the multi-wavelength interactive because I think it's quite hard to conceptualize how we see things in different types of light. And it goes back to the question I answered before. We don't see these things, so how do we represent them? So the fact that we've got these cameras that can see in different types of light and we represent it in different ways, I think it's quite nice and an immersive thing. And I enjoy watching the kids interact with it. Even if they're just like looking at their face in the infrared, they're still like learning something about light.
Amazing. Holly?
I'm afraid I just really love books, so my favorite are the very old textbooks. So yeah, I'm very boring, sorry.
There's nothing boring about old books, Holly. So I think I'm going to squeeze one last question in because I think it's quite an important one, and then we'll wrap up for today. It's just a question around the best way for people who are interested in astronomy and physics and space and all of that sort of good stuff. Is there a central source of information that can keep you updated with new developments and research, updates from organisations like NASA? Is there any way you would recommend to kind of stay on top of that sort of information?
I think personally, I know this is American based, but I think the NASA website is pretty amazing, and it's very public facing. It's very kind of easy to navigate, and they have like a lot of different, like there's an exoplanet NASA page that's amazing if you want to learn about exoplanets. And yeah, I think that's one of the kind of the best, even though I probably should be advocating for Europe, but I just think, yeah, the NASA website's great.
It's maybe worth mentioning too that there's lots of local astronomical societies, and on our website we sort of list those. Hopefully we've got them all, and we'd encourage people to get in touch with those if they're enthusiastic, particularly about getting out there and using telescopes and seeing something.
Amazing. Thanks, everyone. So I'm going to unfortunately have to wrap us up for today. Sorry for anyone who's submitted a question. We haven't had time to answer it. But I'd just like to say a massive thank you to our presenters today for a really insightful discussion, great insight into the Northeast region, and hope everyone can make time to go and see the exhibition and take your families to see it as well. For everyone who's attended today, just a massive thank you for being with us again and joining us from wherever wherever you are in the world, and I really hope that you've enjoyed today's talk. Next up in our Discover series, we are joined by Professor Richard Dawson, who'll be delivering another lecture-style webinar on can we deliver a resilient net zero. So extreme weather events around the world have exposed the substantial risks to people and the economy from climate-related failure of the power system. So Professor Dawson is going to introduce during this webinar the issues around this and set out some of the adaptation actions that are needed to help address these risks and maintain infrastructure that is both resilient and supports net zero greenhouse gas emissions. Registration for this event is now open, and a link for this will be circulated to you following this event. As always, please get in touch with our team if you want to find out more about the alumni community here at Newcastle and ways you can get involved. And you're always welcome to visit our website as well. Just like to finally finish with a massive thank you again to Chris, Vicky and Holly, and to everyone else. Enjoy the rest of your day, and we cannot wait to see you at another event in the future.